Okay, is it visible?
Yes, fine.
Okay, so thank you. First of all, we must thank to the chair and the organizer of this today second international conference. Uh, uh, Thanks to the Science Tech Institution, which has collaborated with the Dr. Sakuntala Mishra National Rehabilitation University. So I think without losing time, we should start. And so we will be discussing about various sampling techniques and their applications in different areas of applications. So now this is the, flow of the discussion. So first question comes into the mind that why sampling? So let me put this way that there are two things, one population and another one is sample. And here the function of the population values and the function of the sample values. So population is the totality of all the units under consideration for the characteristic under study, and sample is a part of that or fraction or subset of the population. And we know that any function of the population values is known as parameter. So population mean, population variance, population correlation coefficient of variation, these all are the parameters. And any function of the sample values is known as statistic. So sample mean, sample variance, sample coefficient of variation, these all are the statistics. And whenever a statistics is chosen to estimate any parameter, then it is known as the estimator of that particular parameter. And the value of this statistic or say estimator for the sample in hand is known as the estimate of that population parameter under consideration. Now, the question arises, why sampling? So it is always good to calculate the parameters rather than to estimate them. But whenever the population is very large, just for example, say India, it is having 140 crore of the population, and it is very hard to get the information on each and every unit of the population. So that is why India organizes the census after 10 years. And it takes 2 to 3 years to get it analyzed. So what is the alternative of that? And that is the sampling. So on the basis of the part of the population, we try to estimate the population under consideration. And so there are various techniques and for suitable for different situations so that we may closely estimate the parameter under consideration. And there are certain areas where sampling is mandatory. For example, in diagnostic tests, we get a blood sample from the body and analyze or estimate the parameters, vital parameters on the basis of this sample. So here we cannot, we don't do the complete animation that we take the whole blood out to the body and then check it. So here this sampling is, mandatory. So whenever the population is very large and it takes too much time, too much money, too much manpower to get the information on every unit of the population. So what we do, we take a part of the population known as sample. And one thing we should keep in mind that this sample should be chosen in such a way that it must be well representative of the population. If it is not well representative of the population, we will get the very badly biased estimates of the parameter under consideration. So sampling is done whenever the population is large. So to save the time, save money and manpower, we get the best estimates on the basis of the sampling, appropriate sampling technique, and we estimate the parameters accordingly. Now there are two types of samplings. The classification of sampling means there are two types of sampling: probability sampling and non-probability sampling. So what is the difference between the two? Whenever we are taking the sample we are getting a unit from the population into the sample through some law of probability, then this technique is known as random sampling. And whenever the unit from the population is selected into the sample according one's own law, suppose we have some red, white, and black balls in a bag, and we are putting out only red balls. So this is non-probability sampling, because here we are applying our own law. It is not random. So it is also known as the purposive sampling or judgment sampling. So we'll later talk about both type of sampling, random and non-random probability samplings. So different types of sampling methods we'll be discussing for both probability as well as non-probability samplings. And definitely we will discuss their relative advantages and disadvantages of different methods. So now the first, here you can see this is population and we have taken a sample. So this is the sample. So sampling is a process. Sampling is nothing but it is only the method or technique of drawing sample from the population, and rest part is of estimation. So sampling is nothing but it is the way or method or technique to get the sample from the population. Now here you can see this is the population, and this is the sample, and this is sample, and there is one more thing, that is sampling frame. So sampling frame is nothing but it is the list of complete up-to-date units of the population. So it is the list of the units which is complete and up-to-date list of units under consideration of the population, and from where we do the sampling. Now there are various type of probability or random sampling, and the first one is simple random sampling, another one is stratified sampling, and then systematic random sampling, cluster sampling, two-stage and multi-stage sampling, two-phase and multi-phase sampling, and PPS sampling. So these samplings are used as per the demand or as per the situation. So there are various situations in the population. So we select the sampling technique on the basis of the situation of the population units into the population. So first one is the simplest one, that is simple random sampling. What we do in simple random sampling, and when this sampling is being applied for the estimation of the parameters under consideration, whenever the population is homogeneous for the characteristic under study, it means the units are almost having similar type of values for the characteristic under study, then it is supposed to be homogeneous. And whenever the population is homogeneous for the characteristic under study, then we use the simple random sampling where every unit has equal chance to be selected into the sample. See, we have the similar type of list, say, and we are randomly just collecting the units into the population. So there are two famous methods for random sampling or simple random sampling. The one is lottery method. We number the units of the population and we get the lottery. We get it out having equal probability to be selected into the sample, or we do it on the basis of the random numbers. So Tippett has given 10,000 numbers, 4-digit numbers, which are random, where you are getting it row wise or column wise or diagonally. Every number is random, and every number is 4-digit numbers are also random. If you are taking single number, single digit numbers, or 2-digit number, or 3-digit number, or 4-digit numbers, so all numbers are random, whether you are selecting them row wise or column wise or diagonally. So every way it is random. So we can we can select the sampling units by either by the lottery method or by through random numbers tables. And now there is features in different softwares and in Excel as well, that rand we apply the command in Excel and we can get the random numbers from the population under consideration. So what are the advantages of this simple random sampling and what are the disadvantages? The advantage is that minimal knowledge of the population needed, because we know that all are similar. So we have to check, we have to select randomly any unit of the population. And it is easy to analyze the data because there is no, outliers are not there in the data. Some extreme observations are not into the data. So easy to analyze the data. And what is the disadvantage? That low frequency of use, because every time we don't get the homogeneous population, so very low frequency it is used, and it does not use researchers expertise, because here there is no need of expertise, or even the expertise is needed, but we don't use it because we see that the population is homogeneous, so we randomly select the units into the sample from the population till the required size of the sample is obtained. And larger risk of random errors. If random errors are, included into the data, then it will come with the sample, and then we can get the biased results. Now, when the suppose the population is not homogeneous for the characteristic under consideration, it is heterogeneous for the characteristic under consideration. So what we do, we make the groups of homogeneous units known as strata. So we partition the whole population into different strata on the basis of the homogeneity within the strata. So this way we make the strata till the and the strata. So as you can see, for example, say in Lucknow or in any city, there are slums in the city. There are colonies with the below average income peoples, and there are some colonies with the creamy layer peoples. So this way we can make the strata. And if you are applying, say, simple random sampling there, and if high income group, say for example in this Lucknow, you are getting the sample from the Lucknow, and you have got 2, 3, 4, or 4 say samples from the Gomti Nagar, very rich area, posh area. So your average income will be hiked, because there a single person is having its average income equal to 1,000 or lakhs of the people of the rest of the city. So this way, if heterogeneity is there in the data, we cannot apply simple random sampling. So what we do, we have to apply stratified random sampling, and stratification is done on the basis of the similarity among the units. So it is the partitioning of the data, partitioning of the area under consideration on the basis of the homogeneity of the units under consideration. So now here there are some certain, definitely there are some advantages and some disadvantages of the stratified random sampling. And the advantages are that it assumes representation of all groups in sample population, because okay, let me say something more about this. Stratified sampling, how we take the sample. So there are 2, 3 methods to get the sample from stratified random sampling from the strata. One is very famous, that is proportional allocation. So we take the proportional sample sizes from the all strata. Suppose we have K strata, so and we have observations in first strata capital N1, capital N2, and capital Nk. So that summation Ni, capital Ni is equal to N, making the whole population. And suppose we have to take a sample of size small n, so we will take N1 from capital N1, N2 from capital N2, and Nk from capital Nk, so that small n1 plus small n2 and plus 1 small nk is equal to small n. So this way we take the proportional allocation, and the another one is optimum allocation, and there are 2 ways to optimize this stratification or optimize the selection, that either you fix the cost and minimize the variance, or you fix the variance and minimize the cost. So it is very easy to fix the cost, and minimize the variance. And it is very hard to minimize the variance, that it fix the variance. We cannot fix the variance. We can fix the cost, because you may have this situation many times, that you have been given fixed price for the as the pocket money, and you have been said that you have to spend this till you have to pass the whole month. Suppose you are given, you are a student and you are given only 2000 rupees by your parents, and you are instructed that you have to pass this month in these 2000 rupees. So this way we have fixed the cost and we are trying to minimize the variance. And now we come to this, and there is one more allocation name as Niemann allocation. There we fix the per unit cost is fixed for per unit cost is same for all the strata. While in optimum allocation, per unit cost is not fixed for R strata. It is not same. It is different for different strata. So now come to the disadvantages of this stratified random sampling. It requires accurate information on proportions of each strata. And stratified list costly to prepare. It is costly. And one more thing, it is very hard to decide the boundary of the strata. So these are some disadvantages of the stratified random sampling. So here you can see, now we come to the systematic sampling. So we have talked about sampling frame, that is complete up-to-date list of all units under consideration of the population make the sampling frame. Suppose available, then we generally use this systematic random sampling, and in most of the government plans we use this systematic random sampling, because here we take only one unit is selected random, rest of the units are automatically systematically selected. That is why it is named as systematic random sampling. Suppose we wish to select some households, and we have the list of voters of a particular area, and then what we do, we select the a number between 0 to the sample size, and we divide the population through the sample size. Suppose we have a population of size 100 and we wish to take the sample of size 10. So we will divide 100 by 10. So it is 10. It is known as interval of differencing, K. So K is also 10 here. So we will take a number, random number. We will select a random number from 0 to 10. And suppose it comes out to be 5. Then the fifth unit into the list will be selected, and then we will keep on adding 10. That is, if ith unit is selected, then I plus k, I plus 2k, I plus 3k, and so on till the required sample is obtained. So we will take the fifth unit, then 15th unit, 5 plus 10, then again plus 10, 25, 35, 45, 55. This way we will get the sample till the required sample size is obtained. So this way we use, and the first unit is selected using simple random sampling. So this way here you can see here that this we have the complete list of units under consideration, that is sampling frame is available. So here you can see here, and we have taken the random number. For example, every 10th person is selected. So you can see here this first, no, here every interval of differencing is 5 here actually. This 6th, 5th, then 10th, then this 15th and 20th, then this way we can calculate the units under consideration. Obviously, every sampling technique is having its limitations and some advantages, and that it is advantage is that moderate cost, because we are just we are not randomly selecting, we are just randomly selecting only one, and then we know where to get observation from the unit systematically. so it is moderate huge because if the population sampling frame is available and then and almost homogeneous population, then we go for the this sampling. So uh, very moderately it is used, and it is very simple to draw the sample and easy to verify because we have all the selected units we know in advance. So disadvantage is that periodic ordering required. This is so there are by this drawback we have two types of systematic sampling. One is known as linear systematic sampling and another one is known as circular systematic sampling. Suppose we have selected a random number through random number tabular lottery system, and we have divided the population size through the sample size. So we have got the interval of differencing, say value of k. But when we started taking the numbers I, then I plus k, I plus 2k, I plus 3k, and so on, and the whole population is exhausted, and we have not completed the sample size. So what we will do in that situation, if we are getting the complete sample till the population is over, then this is known as linear systematic sampling. And if it is not over, then what we do, if the number is more than the size of the population, then we subtract the size of the population. Suppose we have 100 size population and we have three digit numbers, and we have suppose got triple one, 111. So what we will do, we will subtract the population, 111 minus 100, so 11. So 11th unit will be selected into the sample. So this method is known as circular systematic sampling. Now we come to cluster sampling. In what we do in cluster sampling, suppose when the sampling frame is not available, then in that situation we use this cluster sampling. And cluster are nothing but these are the group of the unit, basic units. So here sampling unit is the cluster, and cluster is the unit of the basic units. It is the group of basic units. Suppose we don't know the enrolled number of students of the university, and so sampling frame is not available to us, and we wish to do sampling from this suppose particular university. So what we'll do, we will ask the questions to the group of people, and that group of people will make the cluster. So the cluster may be of two types, maybe of equal size cluster and unequal size cluster. And here, since we are not knowing the sampling frame, so what we do, we make the cluster, we wish to make the cluster as heterogeneous as possible. So it is contrary to that, stratified sampling. What we do in stratified sampling, we make the strata as similar as possible units in the strata, and here we take as heterogeneous as possible in cluster. So whenever the population is not known, suppose in fisheries we are not going the number of fishes in the pond, or so suppose in some forest area we are not knowing the number of trees. So there we will apply this type of sampling, cluster sampling, and it may be of both type, maybe with equal cluster and with unequal cluster. So here you can see this is the cluster having 4 units and this is having 4 units. So this way we can apply the cluster sampling. So what is advantage with the cluster sampling? That it can estimate characteristic of both cluster and population, because clusters are making the population. And what is the disadvantage? That the cost of each, the cost to reach an element to sample is very high, because it is heterogeneous. And so for to get the information on every element of the sample, because samples are nothing but these are the collection of this sampling unit, and sampling unit is the cluster. So cluster is a group of basic units. So its cost is very high. And each stage in cluster sampling introduces sampling error. So when we are using one way, two way, this way, this cluster, and at every stage a sampling error will be included. So more stages there are, the more error there tends to be. If you are using more and more stages.
Sir, sorry to interrupt you, sir. Please, sir. Actually, our next speakers
is waiting. So okay, I am just trying to finish it in next 5 minutes. Okay.
Yes, sir.
So in this situation, we will use the this cluster sampling. And suppose if we are selecting the units in 2 stages, or say in multi stages, then this multi-stage or 2-stage sampling is applied. If we are getting the observation in 2 sample, suppose in first way we have taken the 28 states, and then we have selected 1 state, then we have from 1 state we have selected a 1 district, then from 1 district we have selected a tehsil, then block, then household, village, and then household. So this way we can get the basic unit where we have to take the observation. So we are getting it on multi-stage, so it is known as multi-stage sampling. So here you can see here that state, district, village, household, and then this way we can get the multi-stage sampling. Now we very quickly we come to the non-probability sampling. In social sciences, it is very much applied. So what is we will be discussing convenience sampling, consecutive sampling, purposive sampling, quota sampling, snowball sampling, and judgment sampling. So what we do in convenience sampling, we take the observations on the units according to our convenience. And consecutive sampling is one step ahead to convenience sampling, where we will get the observation on the convenience sample and the addition to that. That is consecutive sampling. And purposive sampling, we will get the samples or units selected into the sample according to our purpose. And quota sampling, this is the non-sampling version of the stratified sampling, where we apply the quota. Suppose we have we have to distribute some say some items to the population, and we have divided the population in different strata, but randomly we will not give it to the person. We will give it to person according to our choice. So this is the quota sampling. And snowball sampling, the very good example of snowball sampling is that if we wish to conduct some survey on, say, transgenders, so we will go to one transgender and it will tell you where the next will be found. So this way, like the snowball, we are giving it to another one. So we will get more and more persons to get the information till the required sample is obtained. And judgment sampling is, obviously it is done on the basis of the judgment, say interviews, or say cricket player selection is done on the basis of the judgmental sampling. So these are the what we have just. This is convenient sampling. It is convenient to call this person from the second floor not to come to the down. So we will do this one. And this way you can get the consecutive. This has been selected earlier, and this is available. Now we will get the sample. So this way, this is purposive sampling. We have chosen only red persons. So and quota sampling. So this way, this quota sampling we have given the as per our choice. So this way, snowball sampling, this person has told about these 2 persons, then these 3, and so on. This way we can get the snowball sampling. And there are 2 types of error: sampling error and non-sampling error. So there are sampling error with the random samples, and whenever you are using non-random sampling with the different non-response and these type of errors. So these are various type of non-sampling errors. So we will be discussing some another day if we'll get chance.